Here's a question. As x approaches infinity, what does this evaluate as? So let's just say that x has reached infinity, okay? Let's bring down the 1 plus 9 over 4 infinities. That looks like an A, but it's an infinity, I swear. To the power of infinity. Let's simplify this a little bit. 1 plus 2.25 over infinity to the power of infinity. Now here, what most people would think is that they see, oh, n over infinity. Oh wait, that was a horrible infinity. Now what some people might think is they see, oh, n over infinity. Isn't that just 0? Wrong, it's not 0. It approaches 0, but it isn't 0. So let's give an example here. N is 2.25. Let's just say n is equal to 1 to make it simple. 1 over infinity. Now you may think that this is 0 because it's 1 divided by a really, really, really big number, and you think as high as that number goes, it'd be 0. But it's not 0. So let's give an example for infinity. Let's do like 1,000. 1 over 1,000 is 0.001, I think. Yeah, 0.001. This is not 0. And the more times you add a 0 here, it's never going to become 0. 1 over infinity can never become 0. And the same thing is true for 2.25 over infinity. So there's a symbol for whenever we have something extremely close to 0, but not 0. And so the name for that term is 0 because it's really close to 0, but it's not 0. So we add a little plus here, which says it's not 0, but it's almost 0. And then to the infinity, so here we have 1 plus 0 plus to the power of infinity. Well, this is just 1 plus to the power of infinity. And 1 to the power of infinity, as previously stated, let's just give an example for what 1 plus could be, like 1.1. 1.1, let's say infinity is 2, is 1.21. Yeah, and so as 1 approaches, as 1 plus approaches 1, this number will get smaller, but it won't ever equal, it's never going to equal 1. But you also may think, well, hey, wouldn't this just be infinity? Because an infinite amount of times? Well, that is also where you're wrong. 1 plus to the infinity's power is not infinity. It may seem like that, but it's not the case. Y approaches 0. 1 plus 1 over y to the y. And this is equal to Euler's constant, which is roughly 2.71828182845. It just keeps going. It's what's the word? It's similar to what pi is. It's irrational. That's the word I'm looking for. It's not rational. So now we have this. So as y approaches infinity, 1 plus 1 over y to the y is equal to e. So now let's bring back our original equation. So going back with our old equation, if we want to have 1 plus 1 over y to the y, like what we had previously with our Euler's formula, then we have to set x equal to something, where 9 over 4x will equal y. Will equal 1 over y. So that's exactly what we're going to do. Let's set 9 over 4x equal to 1 over y. So now we can cross multiply here. 9y is equal to 4x. Let's solve for x and let's solve for y. So y is equal to 4x over 9, and x is equal to 9y over 4. Okay, so let's rewrite the equation. limit. If x is going to go to infinity, then so will y. Because we're going to replace x with y, pretty much. 1 plus 9 over 4. 1 over... And then, what is x? Well, x is just 9y over 4. So we can say 2.25y. And this will be to the x, because we'll just leave x. Actually, no, let's fill it in. Let's decolor this. 9 over 4 is the same thing as 2.25. So 2.25 over 1 times 1 over 2.25 times 1 over y. This will cancel, so we're just left with 1 over y. So 1 plus 1 over y to the 9y over 4th. Let's actually bring down our y approaches of infinity. That is an 8. That is not. Let's bring back this. Let's degroup these exponents. So what we can do is with our exponent rules, we can say that a to the mn is equal to a to the mn. And I'll just give an example here. A m n a to the m n. Same thing here. So how can we use that to describe this? Well, we can say y, we can put y here, and then we can group all of this out, and then put our 9/4, because we factored out this y, now we just gotta put this 9/4 back. And now wait, hold up. Limit y approaches infinity, 1 plus 1 over y to the y, this is equal to e. So e and a 9/4. And if you want to know, this is e to the 9 to the 4th root. That is the most this can be simplified. If you want a decimal evaluation, that comes out to roughly 9.487735836.